lesson 7.7, we are factoring special products. Now, you have heard the words special products before because we had special products when we were learning how to multiply binomials. All right? Those were the problems that had shortcuts. So guess what I'm going to teach you today when we are factoring special products? I'm going to be teaching you shortcuts. Okay? Now, if I'm teaching it to you, you are going to be tested over it. I need to make sure I make that clear because I did allow you with the last set of shortcuts I taught you, I allowed you to go ahead and FOIL if you didn't understand the shortcut. Unfortunately, we can't do that when we are factoring. So I need you to focus. I need you to pay attention, and you are going to be tested over the shortcuts. It's not, you can use the shortcut if you want. Okay? You're going to have to use the shortcut. Now, before we even get into today's lesson, let's go back and let's look at what we have done so far. We have learned 3 types of factoring so far, and by the time we're done with this chapter over the next couple days, you're going to have 6 different ways to factor. All right, so we need to keep these different ways straight in our head. We also have a project this quarter where you are going to have to create a booklet that explains every single type of factoring that you've learned. Okay, so let's go through all 3 types of factoring that you've learned so far. The first one you learned in lesson 7.4. Who can remind us the very first type of factoring that we learned? GCF factoring. That is the factoring where all you can do is pull out a GCF and you cannot go any further. So that is the very first type of factoring that we learned. All right, then last Thursday we learned our second type of factoring. What's our second type? X factoring. All right, we're calling it X factoring because that's exactly what we did. We dropped an X, we filled in all the sides of the X, and we were able to get our answer. So we are going to call it X factoring. Now, what was key about X factoring? When did you use X factoring?
When the leading coefficient was 1.
When the LC equaled 1. Perfect. All right, perfect. So write that down in your notes. X factoring, and this is when the leading coefficient equals 1. And then yesterday we learned probably the most difficult form of factoring so far, which was what?
AC factoring.
AC factoring. And when are we using AC factoring?
When the leading coefficient isn't 1.
Good. So how about we write when the LC does not equal 1? So anytime the leading coefficient does not equal a 1, we are going to do AC factoring. Now, the next thing we need to make sure we're clear about before we move into the shortcuts today, a perfect square. Okay, we haven't talked about this in a while, so we might be going back far in our minds. But what is a perfect square? So put this in your notes, and I've given you 2 options. I've given you the square root of 12, and I've given you the square root of 4. My first question is this: is the square root of 12 a perfect square? Well, here's what I need to know. Is there a whole number times itself that will give us 12? No. That's a perfect square. So I want you to cross out the square root of 12. Now, what about the square root of 4? Is that considered a perfect square? Yes. What whole number times itself will give me 4? 2. So go ahead and write that equals 2. So you have to know what a perfect square is. It's the whole key to our shortcuts today. Now that leads us into the essential question. It says, how can you recognize and factor special products? And guys, this is the key right here. You have to be able to recognize. All right, highlight the word recognize. If you don't recognize the shortcut, then you're either not going to be able to do the problem, or you're going to waste a whole lot of time doing extra work that you don't need to do. So you've got to be able to recognize the shortcut. Now, one of these should look familiar to you just by the title of the special product. Do either of these look familiar to you? You've seen it before when we multiplied binomials and we learned our special product shortcuts. Difference of squares. You have seen the difference of squares. All right, but this time, remember, factoring is the opposite of FOILing or multiplying, so that's what we're doing. We're working backwards this time. Now, the difference of squares is when both terms are perfect squares. Okay, both terms have to be perfect squares in order for this to work. Also, if you look at the formula, it's a squared minus b squared. That's the only formula for the difference of squares. What kind of a problem is this? And this has 2 different answers. When I say what type of problem is this? What operation Let's start with that one. What operation is this problem? Subtraction. Now, doesn't that make sense? It's the difference of squares, and the difference is the answer to a subtraction problem. So the only way this shortcut works is if it's a subtraction problem. Now, you should also notice, because this is a little different than what we've been doing so far, what type of polynomial is the difference of squares? It's a binomial, right? It's only got two terms. And so far, we have been factoring trinomials. So that's the other clue for you. How do I know when it's the difference of squares? It's going to be a binomial, and it's going to be a subtraction problem. And of course, both terms are going to be perfect squares. Now, look how we solve it once we figure out it's the difference of squares. How many parentheses are in our answer? Because this is our answer right here. So highlight your answer. How many sets of parentheses are in our answer? 2. And what is the only difference between the two parentheses? The signs. All right, so we're going to have 1 plus, let me circle that a little bit better, 1 plus and 1 minus. The first terms are going to be the same. The second terms are going to be the same. Now, look how we find those terms. You find the square root of each term, and the signs will be different. That's how quick and easy it is to factor the difference of squares. You find the square root of each term, and the signs will be different. Now, the second type of special product that we're looking at today is called the perfect square trinomial. So right there in the title, it tells you, and you can look at the formulas if you're not sure, what type of polynomials are these going to be? A trinomial, right? 3 terms. It calls it a perfect square trinomial. So what is a perfect square trinomial? Well, it's when the first term and the third term are perfect squares. When the first term and the third term are perfect squares. So I would highlight first term, I would highlight third term, and I would highlight perfect squares. And if you wanted to, next to difference of squares, you could highlight both terms and perfect squares. But a perfect square trinomial, only the first term and the third term are going to be perfect squares. Now, I also want you to look at the formulas that I've underlined. You've got a squared plus 2ab plus b squared, and you've got a squared minus 2ab plus b squared. What's the only difference between these two formulas?
Signs.
Which signs, though? The first signs. Does everyone see? Only the first signs are different. So what does that tell us? If we are in fact dealing with a perfect square trinomial, what has to be true about the second sign? Not the same. That's a good guess, but it's not that they have to be the same. These are the formulas. In both of these formulas, what is the second sign? Positive. So the key to a perfect square trinomial, the second sign has to be positive. And we will practice that as we go. All right? Now, look at the answer to both of these. Whether it's a squared plus 2ab plus b squared, or whether it's a squared minus 2ab plus b squared, what do you see about the answer? How many binomials are in the final answer?
2.
No. There's one binomial in the final answer, and that binomial is raised to the second power. Does that look familiar? Because that is this special product you learned called the square of a binomial. So it's the opposite of what you've already learned. Okay, we're working backwards because, like we said, factoring is the opposite of FOILing or multiplying. But you've got to understand, when it's a perfect square trinomial, your final answer is going to be 1 parenthesis raised to the power of 2. Now, I've listed the steps for you. So grab your highlighters. You find the square root of the first and third term. The sign will match the first sign in the original problem. That's your second step. And then lastly, you will multiply and double to check the middle term. You will multiply and double to check the middle term. And I would also go back to the difference of squares. Highlight those steps. Find the square root of each term, and the signs will be different. Now, looking at example 1, it says factor the expression. So we're going to switch this up a little bit. I've been asking you every day, what type of polynomial, what is the leading coefficient, but what if we just went straight into the question, is there a GCF? Because whether it's a special product or whether it's not, we always are going to have to be pulling the GCF out first. So let's make that the first thing we ask. is there a GCF? So looking at letter A, is there a GCF?
Sure.
All right, you say sure, so what is it? Is there a number or a variable, or both, that goes into both terms? No. There's not a number. There's only one number in the problem, and there's only one variable. So there is no GCF. So now let's ask the question, what type of polynomial is it? It's a binomial, which we are not typically seeing so far. So that right away should make us stop and think, oh wait, I think this is probably a shortcut problem. Is this the difference of squares? So let's keep going. We asked, it's a binomial. Okay, sorry, I lost my train of thought. It is a binomial. So is it a subtraction problem?
Yes.
Yeah. And are both terms a perfect square? Is the square root of 100 a perfect square? Is the square root of m squared a perfect square? Yes. So this is a shortcut problem. So how many parentheses are supposed to be in our answer when it's a difference of squares? 2. So we've got one set and we've got another set. Now, what do we know about the signs? Because we can go ahead and plug those in as well. They're different. You got one that's plus and one that's minus. Now, the only thing left to do is to find our terms. And what do we do to find the terms? If you're not sure, go back and look at what you highlighted. Find the square root of each term. So here's a great reminder, and we're going to do this in our notes. You do not have to do this on tests and quizzes and homeworks, but let's do it in our notes. Okay, let's draw the little square root symbol over the terms. So what is the square root of 100? So each binomial gets a 10, and what's the square root of m squared? M. So each binomial gets an m, and this is our final answer.
That's it.
Let's move on to letter B. Right off the bat, is there a GCF? Okay, we're now going to switch our train of thought, and we're always going to ask this first. Is there a GCF? Because shortcut or not, we've got to pull out GCFs. Okay, no GCF. What type of polynomial are we working with this time? A trinomial. Now, what's the leading coefficient here?
1.
And so far, when we see the leading coefficient is a 1, what type of factoring have we done? Okay, but guess what? Now we have a new question to ask. Is there a shortcut? So here's how we check. If it's a trinomial, we check and see if the first term and the third term are perfect squares. Now notice what I highlighted with the third term. I highlighted the what? Sign, okay? Because I've got to make sure that the second sign is positive. If it's not, the shortcut doesn't work. So, does it have the right sign? Yes. So then the question, is the first term, is the third term perfect squares? Yes. So this is a shortcut. There is no reason for us to drop an x and start x factoring. This is a shortcut. So, perfect square trinomials have how many parentheses in the answer? 1, and it's raised to what power? The second. Now, the sign, we didn't really talk about this yet, but what do you think the sign of your answer is going to be? Whatever the first sign is. So the first sign in the original problem is a negative or a minus. So yes, we drop that sign down into our answer. Now, how do we find the terms? Square root of the first term, square root of the third term. So again, put the square root in your notes. You don't have to do this later on, but in your notes, show yourself what you've done. What is the square root of m squared? M. And what is the square root of 1? 1. Now, last step, we've got to check the middle term, because if the factors do not give us the middle term, this isn't a shortcut problem. And we've got to go back and do all that x factoring. Okay, so over to the side, you're going to write 2 times a times b. And yes, this is something you will show me on quizzes and tests and homework. Okay, what is the a? Now remember, a is the first term in your answer, b is the second. So what is the a of your answer? What's the first term in your answer? No, not in your answer. This is our answer. M. What is the second term, or the b? -1, okay? It is a -1. So multiply those 3 things together. What's 2 times m times -1? -2m. Is that the sign, or I'm sorry, is that the middle term in your original problem? Yes or no?
Yes.
Yes. So guess what? This is my final answer. Letter C. First question, is there a GCF? No. What type of polynomial is it? All right, so now I'm thinking, is there a shortcut? It's a binomial. Is there a shortcut? Well, is it a subtraction problem?
Yes.
Are both terms perfect squares?
Yes.
Yes, no? I hear one yes. I want to hear more yeses. Are they perfect squares? Okay, so this is a shortcut problem. How many parentheses are going to be in our answer? And the signs? It's the difference of squares. So guys, my signs are going to be different. Okay? Kendall, how do I find the terms of my two binomials? Square root what? The first term and the second term. Okay? Now, square root the entire term. Javon, what is the square root of 9n squared? Square root of 9n squared is 3n, so each binomial gets a 3n. Remember, you have to square root the entire term. And then what's the square root of 16? 4. So each parenthesis gets a 4, and there is my final answer. All right, letter D. First question, is there a GCF? Mason, is there a GCF? Yes. Bailey, what is that GCF this time? 9. You look at the smallest number and hope that it's the GCF. And in this case, it is. So we're pulling out a 9. Continue to keep in mind, variable GCFs are possible, but is there a variable in every single term in the problem? No, then you can't pull out a Z for this one. So we start dividing. What's 9Z squared divided by 9? Z squared. You can put the 1 in front. You don't have to. Drop the plus sign. What is 36Z divided by 9? 4Z. And drop the plus sign. What is 36 divided by 9? 4. Now, remember, once we pulled out the GCF, we focus on our new problem in the parentheses. In this case, a new trinomial. Is there a shortcut? What's the leading coefficient? A 1, but we still have to ask first, is there a shortcut? So what are we checking to see if this is a shortcut problem? The first term and the third term. Do I have the right sign with the third term? I got one person that says yes. Yes, remember the second sign has to be a positive for this to work. Okay? Are the terms perfect squares? The first and the third term perfect squares? Yeah. So this has a shortcut. This is a perfect square trinomial. How many parentheses are going in my answer? 1 raised to the second power. What's the sign in my answer?
Z.
The sign.
Positive.
Good. Remember the first sign in the problem comes down into my answer. So this is a plus sign. And how do I find the terms of my binomial? Square root. What am I square rooting? Z squared and 4. So what is the square root of Z squared? And the square root of 4? 2. Now, am I able to box it in yet? No, I've got to check for that middle term. So over to the side, 2 times A times B. What is my A? Z. And what is my B? 2. So what's 2 times Z times 2? 4Z. Is that my middle term? Yes. So this is my final answer. Correct? Anybody want to say no? You should be saying no. This is not my final answer. What did I forget in my final answer? Which is the GCF. Okay, remember we talked about this yesterday. You've got to go back to the beginning of the problem, and if you had a GCF, you have to bring it down into your final answer. All right, letter E. Right off the bat, what's the first question we're now asking?
Is it squared?
Nope.
Is there a shortcut?
Is there a GCF? Okay? Is there a GCF? Because again, regular problem or shortcut problem. We have to pull the GCF out first. So is there a GCF in this one? No. So then we ask what type of polynomial? Binomial. Is there a shortcut then?
Yes.
Yeah, because it's a subtraction problem and each term is a perfect square. So how many parentheses are in your final answer? And the signs? Different. And how did you find the terms for your binomial? Square root what? Good. Good. Both terms, the 16h squared and the 49. So what's the square root of 16h squared? 4h. So each binomial gets a 4h. And fix this a little bit. And what about the square root of 49? 7. So each binomial gets a 7. How many of you had this one right? Awesome. All right, letter F. Right off the bat, is there a GCF? Everybody. First question we're asking, is there a... No. Tell me what the question is. Is there a GCF? And the answer is no. All right, what type of polynomial?
Try.
Which means we still can look for a shortcut. All right, what are we looking at for the shortcut? First term, third term. Now, does the third term have the correct sign? Yeah, listen. If this were a minus sign, we would have to X factor. A shortcut isn't even an option. So keep asking yourself when you're checking the first and the third term, check that second sign. All right? Are they perfect squares?
Yes.
D squared and 25? So this is a shortcut problem. How many parentheses should be in our answer? Raised to the second. All right. What sign's in our answer? Negative. Remember, first sign in the problem becomes the sign in your answer. And how do we find our... Noah, how do we find our terms here? What are we square rooting? D squared and 25. So what is the square root of D squared? And the square root of 25 is 5. Now, we got to check it. So over to the side, if you didn't do this, add it. We got to do 2 times A times B. What is the A here? And what is our B? Careful. Negative 5. So when we multiply those together, we get... Is that our middle term? Yep. And so this was your final answer. How many of you got the correct final answer? Awesome. Now look at example 2. I want you to notice something. You have seen these directions in the last 2 lessons. Solve the equation. However, they're usually followed with the words by factoring. All right, here's what I need you to start getting used to. If I say solve the equation, I don't necessarily have to follow it up with the directions by factoring. You need to know by now, in order to solve these types of equations, you're going to have to factor first. You can't just take the pieces you see and set them equal to 0. So it may or may not say solve the equation by factoring. It just needs to be part of what you do now. Okay? Now, first things first. Is everything on one side set equal to 0? Because we can't solve an equation in these types of problems if we don't see an equals and a 0. So we have everything on one side set equal to 0. So let's start our questioning. First things first. Is there a GCF? So look at letter A. Is there a GCF? No. What type of polynomial is this? Trinomial. And let's check for a shortcut. What do we look for the shortcut? First and third. Now, is the correct sign, is the second sign the correct sign? Yes. Are both terms perfect squares? Now, I hear the hesitation, and I know it's because there's a fraction, but don't let the fraction confuse you. Look at 49, the numerator. Is it a perfect square? Is the denominator 36 a perfect square?
Yes.
Then guess what? The fraction is a perfect square. So this is a shortcut problem. How many parentheses are in our answer? 1, and it is raised to the second power. What sign is it going to be in our answer? A negative. And how are we going to find our terms? Square root. Square root. What's the square root of W squared?
W.
And what's the square root of 49 over 36? 7 over 6. Very good. The square root of 49 is 7. The square root of 36 is 6. Now, we got to check that middle term. All right. So let's do 2 times A times B. What is our A this time? And what is our B? Negative 7, 6. Now, be careful when you multiply. Okay. 2 is technically over 1. So when you multiply 2 and negative 7, 6, what do you get? You get negative 14 over 6. And then what happens to that fraction? It reduces. What goes into both 14 and 6? 2. So what is 14 divided by 2? And what is 6 divided by 2? So you have negative 7/3 W. Is that your middle term? Yeah. Now go back to what appears to be our answer. But have we brought down what we have not used? No. What have we not used yet? Equals 0. Very good. Now, how many equations are we going to write and solve now that we have this problem factored? Just one, okay? Yes, the binomial is raised to the second power, but what's the point of working the same equation twice? We're going to get the same answer. So, what is the equation that we're going to set up and solve? Good. Remember, you take the binomials of your factored answer, and that becomes the equation you set equal to 0. Now, how do we solve for W? We add 7/6. So what does W equal? 7/6. Letter B. Is there a GCF? No. What type of polynomial is it?
Trinomial.
So,
Binomial.
binomial. Is there a shortcut? Well, let me ask. Is this a subtraction problem?
Yes.
Are both terms perfect squares?
Yes.
Then is there a shortcut?
Yes.
Yeah, how many parentheses? 2. And the signs are?
Positive or negative.
Good. How do we find the terms of our binomials? Square root both terms. What's the square root of n squared? N. So each one gets an n. And the square root of 81? Each one gets a 9. Are we finished? What do we got to do? Bring down what we have not used. And then we have to write 2 equations. What is the first equation? N plus 9 equals 0. And n minus 9 equals 0. How do we solve for the first n? Subtract 9. So n equals negative 9. And how do we solve for the second n? Add 9. So n equals positive 9. And those are both your answers, and that is lesson 7.7.